My name is Erik Brunvand. I'm a professor in the CalArts School of Computing at the University of Utah in Salt Lake City. A tiny bit about me, my own research is not in HCI. My research group is interested in domain-specific computing, particularly for computer graphics. So I guess there's a little bit of HCI-ish computer graphics-y kinds of things, but I'm really more of a computer architecture researcher. But I do have a very strong interest in how arts and technology can collaborate in both education and in research to the benefit of both arts and technology, which I think is an important way of thinking about it. And so my talk today is really to just bring up some ideas of how computational thinking and design thinking are natural partners, how you can think about connecting between technology and arts, and maybe just bring up some history that you may not be aware of. Now, you may all know this stuff, and that's great, but if you haven't heard of some of these things, hopefully it will be a little catalyst to go and look up some of these arts projects from the past. So the question really is, technology and the arts, are they compatible at all? I think they are. I think probably HCI researchers are more friendly to that idea than some audiences I talk to. But that's really the crux of what we're talking about. So I refer back to a lecture from 1959 often. This is C.P. Snow, who was a chemist at Cambridge in the UK. He gave what's called the Reed Lecture at Cambridge, which is a famous lecture because it's got a name, about arts and basically about the two cultures of, in his case, humanities and science. But the things he was talking about in 1959 are really very, very relevant to technology and arts in the same sort of context. And in his lecture, the entire point of the Two Cultures lecture, which has been published in a book that you can obviously go find now, is lamenting this separation in how these disciplines have diverged over time and how people in the humanities, people in the sciences, people in the arts, people in technology cannot really communicate the way that they used to. So at the risk of reading out loud a long quote, he says, "I believe the intellectual life of the whole of Western society is increasingly being split into two polar groups. And this polarization is a sheer loss to us all as a people and as a society. It is at the same time practical and intellectual and creative loss, and I repeat that it is false to imagine that these three considerations are clearly separable." So it's a wonderful, well, actually, it's mostly a wonderful lecture to read. He goes off on some strange things, you know, it's 1959, but I do encourage you to check it out because there's some very relevant discussions about how people in these seemingly disparate fields can learn to communicate better to the benefit of us all. And so I take sort of inspiration from that to think about how to combine arts and technology to the benefit of both of these fields. And it's really important to say both ways because depending on who you're talking to, you can easily see perhaps how technology can enhance the arts. And it may be a little harder, at least in some circles, to see how arts can enhance technology. But I believe it really does benefit both camps, especially if you think about it in the right way. So I'm going to go through some very quick slides on ancient history, just thinking about how artists have embraced new technology. Artists are very good at finding new bits of technology and using it for their own purposes, whether or not that was intended for that technology in the first place. So Naum Gabo in 1919 and 1920, this is a very simple sculpture. It's basically a metal rod with a motor in the base that spins the rod, and because there's a counterweight on the rod, when it spins, it expands into a shape. The name of the piece was Kinetic Construction Standing Wave, and it's the first example of something that would be considered a sculpture by an artist that included a motor. It's also the first piece of work that used the title with the word kinetic in it. So this is in some ways the first kinetic sculpture. Marcel Duchamp, an artist you should be familiar with if you look at the history of art in any context, also in the 1920s built this rotary glass plate precision optics sculpture with the help of another avant-garde artist, Man Ray. It's a very simple sculpture when you really think about it. It's some glass plates on rods with a motor that spins. But put yourself in the context of 1920. This is a sculpture with a motor that needs to move in order to actually do its sculptural thing. So this is actually pretty cool stuff. Whoops, this was supposed to play automatically. Laszlo Moholy-Nagy is another artist, another avant-garde artist of the time. You can tell they're avant-garde because the movies they made of their work have really cool avant-garde titles. We don't need to see all of the titles because it takes a while before you actually get to the piece that they're talking about. These are the avant-garde titles from the 20s, spinning titles on spinning balloons. But if we zoom ahead to the actual sculpture, this is a collection of lucite, which was a brand new material, of course, in the 1920s, and kitchen items sort of assembled into a thing that moved around and sort of individual pieces moved together and the whole thing rotated. One of the interesting things about the light space modulator, what a great name, by the way, the light space modulator, is that when Moholy-Nagy talked about this, he didn't really think of this thing as the sculpture. He thought about the shadows and the shapes on the wall that were interacting with the light as really part of the sculpture, which I think is sort of a lovely way of sort of looking forward to the kinds of projection and other kinds of art that we would be more familiar with today. Jean Tinguely was an artist, a Swiss artist, who built a series of what he called metamatics in the 1950s. These were sculptures that made drawings. So they're mechanical sculptures that, through their sculptural artistic performance, made drawings. And when you read some of the things that Tinguely would say about these metamatics, he would be very clear that, the thing itself was a sculpture. That's part of the art. But it makes a drawing, which is part of the art. But it's also a performance because you see the drawing being made in the process of the thing moving. And so the performance was part of the artwork as well. So he was really exploring all these different aspects of where the art is when you have one of these pieces that moves and also makes marks. I'm told that at this kind of opening he would sort of rip off a piece of this and say, here, you have some art. I wish I had one. I would put it on the wall. Desmond Paul Henry was a philosophy professor at Manchester University who had a fondness for mechanical devices. And what he discovered was that there were these really complicated analog computers in World War II bombers. These were bomb site calculating computers. They're analog, but they had very complicated series of gyros and gears and components, and the bomb engineer would put in all the airspeed and the weight of the bomb and the temperature, and it would tell it when to open the door and drop the bomb. Well, he repurposed that into a delightfully complex drawing maker, so he made these drawings using this repurposed analog computer. And then we get to slightly more modern, 1960s at Bell Labs, and this gigantic room-sized thing was the first microfilm printer that they installed at Bell Labs. So this was the printer. This tape drive was the input for the printer. Turns out the reason this printer was so huge is it was actually projecting onto a cassette of microfilm. And so it was drawing directly by exposing lines on the microfilm. And then half of this printer was a wet lab developer for the microfilm. So it was like those drive-in labs, if you're old enough to remember, sort of going and dropping your film off at the photo booth. But he, as a researcher at Bell Labs with this brand new printing equipment, said, you know what, I bet I could write Fortran code to make images. And so he started writing code to generate images directly on the microfilm. Ivan Sutherland should be a name that, if you're not familiar with, I encourage you to become familiar with because he's really, 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 really smart. In 1963, for his PhD dissertation at MIT, he, and I'm not exaggerating, invented interactive computer graphics. Pretty much everything that you think of that is involved in interactive computer graphics on a screen, he invented. It's crazy. And the way he did it is that as a graduate student, he said to his advisor, Claude Shannon, another name that is kind of up there in the pantheon of computer science, he said, Claude, there's this computer in the basement, the TX2. It takes up the whole basement, but it's got a screen and it's got a light pen. I would like to make a package that I can sit and draw on that screen. And his advisor said, Ivan, you're a smart guy. I have no idea what you're talking about. Why would anyone want to sit at a screen and draw on the, okay, fine, go do it. But you can only do it between 3 in the morning and 5 in the morning because that's when the computer's not being used. And so he had his own personal computer, the size of this room, from 3 to 5 in the morning, and he invented interactive computer graphics. He also invented VR, by the way. Not really invented, but he and his team at Harvard built the world's first VR headset called the Sword of Damocles because the headset involved strapping CRTs to the side of your head, so you think about maybe 10,000 volts right at your temples, which was kind of an interesting way of putting things on the screen, and then mirrors that would project those images into your eyes. And it was so heavy that there was a support system that went up to the ceiling that looked like a sword over your head. So, but the original VR headset was also something that Sutherland and his group did. I actually took a lot of slides out of this presentation, but I think I left too many in. So I'm going to move fairly quickly, and I hate it when speakers say that, but at least you'll see little snippets of some of these things. 1966 had a seminal event in technology and arts collaborations, which was the 9 evenings of performance art through the EAT program, which was Experiments in Art and Technology, a group of progressive artists in New York, including John Cage, including Merce Cunningham, including Rauschenberg, and a bunch of researchers from Bell Labs who were paired up with these artists to do performance technology arts performances. It was a bit of a failure in the art sense. It was a grand goal to get these artists connected with these Bell Labs researchers to do amazing things. Many of them did not work quite as well as they hoped, but historically speaking, it was huge. And people who look back on this sort of see this as one of the seminal events, one of the first kinds of really tight arts and technology communications. Billy Kluver was one of the co-organizers. He was a Bell Labs researcher, and he talks about Rauschenberg's strong commitment to collaboration. And this was not something that artists would talk about with their technical partners at the time. The idea that you would consider your technical partner a collaborator and not just a technician who was helping you do the art was radical. But this was fundamental to the way that Kluver and Rauschenberg wanted to set up the 9 evenings. Another seminal event was a show at the Museum of Modern Art in New York, The Machine as Seen at the End of the Mechanical Age. It was works including Leonardo drawings all the way up to arts and technology collaborations from EAT. Another great historical event in the world of arts and technology was the Cybernetic Serendipity Show in London in 1968, which was thematically centered on this relation of computers and creativity. These are some pictures from the Cybernetic Serendipity Show in 1968. I think it's fascinating how much this looks like something we could imagine seeing in a gallery today. Sure, the computers are a little different. There might be more wires, but it kind of looks very familiar if you're thinking about how you could launch a show of computer and arts technology. And then a little bit of sort of art historical reading for the very curious, because some of this art historical stuff is hard to read. But Jack Burnham was an art critic who wrote a lot about the emergence of technology-mediated artworks. And so he particularly was known for what he called the systems approach to sculpture, where it was not the physical object that was the sculpture, it was the system that was implied by the work that you're doing that was really where the art was embodied. And so, like I say, some of these are a little hard to get through if you're not already familiar with how to read art historical criticism, but systems aesthetics from Artforum in 1968, real-time systems from 1969, wonderful stuff, one foundational stuff in how to think about the system as the art as opposed to the artifact as the art. And one of the things Burnham did is he organized a show in 1970 called Software that was very specifically and very intentionally all about how you could use software as a medium for making art. And it was 1970, very early attempt at sort of showing this kind of thing. Again, not everything worked perfectly. This one had a little bit better sort of critical review at the time because I think the critics were sort of coming around to this idea that maybe there was something to this technological collaboration. Don't want to read all of this, but basically he's saying that he doesn't think computers are going to create art. I'm not sure whether we all agree with that now with DALL-E and diffusion and all these other sort of AI art generators. But his point was that the computing was going to be a very helpful tool in the creation of these kinds of creative works. Ed Catmull and Fred Park were early researchers. You may know Ed Catmull's name. He was the founder of Pixar and ended up being the president of both Pixar and Disney. This is one of the first animations that he made with another grad student at the University of Utah in 1972, again with the titles. People love making titles. But basically this was, Ed Catmull's a fascinating guy because from when he was a grad student until he retired, his entire life goal was to make computer animations. So when he got to the University of Utah in 1970, he said, I want to make computer animations. And the faculty at the time said, that sounds hard. And he said, yeah, but I'm going to do some back of the envelope calculations, and I think we could, given what I think I know about Moore's law and about how computing is accelerating, I figure in 20 years we'll be able to make a feature film. Turns out Toy Story came out about 20 years after he said that, so he did a really good back-of-the-envelope calculation, but it required that you believe in exponential growth, because that's a very hard curve to sort of understand if you don't do the math and believe it. In the 1970s, people were making more of these computer-assisted drawings, sort of in the mode of A. Michael Knoll. Of course, Namjoon Paik was building lots of sculptures that involved then high-tech CRTs. Now we think of them as retro, but at the time he was one of the few really mainstream artists who was doing work with CRT displays. Turns out Andy Warhol was a computer artist. This was only discovered after he passed away. Someone said, what's that big box of computer discs in his effects? And somebody said, I don't know, they kind of look like Amiga discs. You all who remembers the Amiga PC? The three old guys in the room. The Amiga was a PC in the 1980s that was notable for its graphics. It had better graphics than any other PC you could buy, which doesn't mean they were great by today's standards. It just means they were better than some of the others you could buy. And it turns out Andy Warhol, he's making a drawing of Debbie Harry there from Blondie. So he made a whole bunch of these drawings, and they were just sort of tucked away on computer disks, and they had to sort of reconstruct how to read Amiga data files to see what was on them. But it turns out he did a whole bunch of these drawings just for himself that were never published in his lifetime. Of course, 1980s brought CGI to the table with Tron in 1980. Was it 84? Was it 82? I don't remember now off the top of my head. So now I want to just show you some snippets from some more contemporary arts and tech kinds of sculptors. Jim Campbell is a San Francisco-based artist who's very interested in low-resolution graphics, not high-resolution graphics. So this video that you're seeing is basically a string of LEDs that are placed about 3 inches away from the wall, so they're projecting backwards onto the wall, making big, fuzzy, indistinct pixels. And then he's projecting home movies on this very low-res screen as an intentional way of sort of getting it to be impressionistic and blurry. This piece is a piece with liquid crystal display where the closer you get, the more opaque it gets. So when you try and examine it closely, you can't see it anymore, and you can only really see it when you get back further away and can't see it very well. This is a piece that he had installed in the San Jose airport. I'm just saddened that it's not there anymore. The last time I flew through San Jose, I went looking for it, and something else is there now, so they took it down. But again, this was a low-res display made of tens of thousands of LEDs in little ping pong ball diffusers hanging from the ceiling of the San Jose airport. And so as you're waiting for your plane to depart, a swimmer would swim by on the ceiling every once in a while. It was mesmerizing. I'm not sure he's completely serious, but this is really a nice distillation of how to make computer art. This is Jim Campbell. It's on his website. It says, this is how you make computer art. You take some input, some position, some color, some movement. You have an invisible computer that interprets that input, and it causes something to happen. The robot moves, something lights up. This is it. I mean, yeah, he's not completely serious, but it's kind of it. You know, you take some environmental input, you do something to it with invisible computing, and you cause something to happen. Shazam! Got computer art. Maybe. Oh, this is me. I just want to show, I don't want to talk too much about my work, but I do dabble in this stuff. This is a piece that I built a number of years ago to address some issues of security. I built this whole little city, and I had these cameras zooming in on little people, and I had lots of CRT surveillance monitors. This is a piece I did with a sculpture professor at the University of Utah. It is a piece where you're invited to touch these brass hands, but you can't actually reach that far, so you have to make a connected chain with other people. And it turns out that the more people you have in the chain, the more this fractured image coalesces on the screen and becomes a full image. And the distorted audio goes away. So the more people you have in the chain, the more complete the image becomes. And because I'm a computer architect and build integrated circuits as part of my research, I've also put little designs on these integrated circuits. This little bird here is about 300 microns by 300 microns. So you have, if I pass the chip around, which I should have brought, I didn't bring a chip. I should have thought to bring a chip. You'd have to sort of trust me that it's there, because you can't really see it without some magnification. But it occurred to me that these layers of materials that we're putting down on integrated circuits look different under a microscope. So the natural question is, can you use those layers sort of like screen print paint layers to make an image? And it turns out you can. It also turns out that if you collaborate with another artist at the University of Utah and you put these very sort of fractured images on the chip, you get in trouble, because the people who are doing quality control looked at that chip and they said, oh man, the metal is cracking. Shut down the fab line. And they got really mad at me because I said, no, it's supposed to look like that. They said, don't ever do that again. Daniel Rosen is a professor at NYU in their strangely named, oh, now I forgot the name, Interactive Telecommunications Program, ITP. He's been there for many years, and he builds what he calls mechanical mirrors. So the idea that he had was, if you take some piece of mechanics and you can make it either bright or dark, then you can use that as a pixel. So this wooden screen up here, the wooden mirror, has thousands of, actually hundreds, I guess, maybe not quite 1,000, little polished pieces of wood with servos behind each one, so you can tilt it backwards or forwards. And if you tilt it backwards, it looks bright, and if you tilt it forwards, it looks dark. And so there's a little camera in the middle doing some image processing and just adjusting each one of those pixels to make a low-res physical mirror out of wood instead of out of mirror materials. Now, he's built a lot of these different mechanical mirrors. This one has chrome balls that either go in or out to make light or dark. So now the question is, if all you need is something that can be either light or dark, you've got an incredible palette of things you can use to make mechanical mirrors, including toy penguins, which is one of my favorite mechanical mirrors. So if you have toy penguins and you rotate them to either show their bellies or show their back, you have black and white pixels. So now you can make a mechanical mirror out of 1,000 penguins. We'll get to the actual mirror part in a second. There it is. I mean, who wouldn't love this piece of art, right? Alan Rath is another San Francisco-based sculptor who uses robotics in his sculpture. One of the things that he leverages is our built-in lizard brain connection with eyeballs. You know, it turns out that when you look at somebody, even if you're just a tiny child, you look straight into their eyeballs because that's sort of how we're wired. So anything that has eyeballs on it automatically looks either human or creepy, depending on how you put it together. So he's got a number of these works that have these tiny little CRTs. Those itsy bitsy little CRTs were actually the CRTs that were in the monitor for television cameras back in the 50s and 60s. So when you looked in, you were looking at one of those little teeny screens, and now he's leveraging those in his work. But he also does a number of other sort of non-creepy, well, depends on how you define creepy, I guess, other works that sort of combine robotics and organic materials. Very simple idea here. The idea is that if you have a lot of these little motors that can move in synchrony and you put long pheasant tail feathers on them, that the organic movement of the feather combined with the mechanical movement of the quick twisting makes a very compelling combination. This particular piece was not interactive. It just did its own thing, but people thought it was, and so people would come up. I saw this piece in the San Jose Museum of Art, and people would try and interact with it because they figured it must be interactive, and so people would sort of, and they'd do something and something would happen and they'd think, oh yeah, I'll try that again. And then it didn't happen. So I don't know whether he was playing with the audience or not, but he builds a number of these sort of robot-based things. Now, interestingly, Alan Rath and I just lost his name. Jim Campbell were both electrical engineering undergraduates at MIT before they decided to become artists. So they are from the transition generation where if you want to do technology-mediated, robotic, kinetic, computer-controlled artwork, you have to have an electrical engineering or computer science background because the tools were such that you had to build a lot of your own stuff. And I think that one of the wonderful things we have nowadays is that the state of the art in embedded controllers, in motor controllers, in just the support you need to get something like that built has accelerated to the point that it's available to almost anyone now. So they were a wonderful sort of transition between when you needed Bell Labs, when you could do it yourself, but you needed a technical background, and now the tools are there for almost anyone. Peter Vogel is a Swiss artist who builds electronic sculptures that make sound. And the interesting thing about these sculptures, at least to me, is that these are electrical components that make up the sculpture, but they are not just decorative. The circuit that is being built is actually built out of those electrical components. So this is actually a circuit that makes sound as part of the sculpture, and he's just very good at making it look cool while he's building it, so not on a printed circuit board. This is the one piece that does have some sound on it, so I'll turn my sound up a little bit. This one is interactive, so this is the artist interacting with one of his sculptures on the wall, and those little black dots are light sensors. I don't know if we're getting sound through the main feed or not, but by moving his hand over the different parts of that sculpture, he's triggering different sound actions that are all generated from the circuits that are on the wall. But again, I don't want to play too much of it because I want to get through the slides and have time for questions. Jack Dahlhausen also builds sort of exposed circuits, but in a much messier style. Peter Vogel's Swiss. I don't know if that implies anything about his preference for very highly designed, tight things. Jack Dahlhausen is a professor of art at Washington State University in Pullman. Leo Villarreal, I think this sound is not important for that, is another artist who uses large arrays of LEDs. This is in the tunnel between the east and west buildings of the National Gallery of Art in DC. If you look at the label for this artwork, it will say that it's 40,000 LEDs and Mac Mini is the medium. His work is very generative, and can scale. It turns out that one of his palettes is the Bay Bridge in San Francisco, where they've installed LEDs on the support columns for the Bay Bridge, not the Golden Gate Bridge, the Bay Bridge over to Oakland. And every night, different generative shapes appear on the Bay Bridge. It was supposed to be temporary when they put it up. People liked it so much they found the funds to make it permanent. So the next time you're in San Francisco down by the water, check this out. If I zoom forward, you can see a sort of more interesting patterns here. But think big. Why stop at a wall? Why not go all the way to a bridge? So that's, wow, I really am staying on time. Maybe I should slow down. So that's really part of what I really wanted to get you all thinking about is how engineering problem solving and creative design thinking are really two halves of sort of the same problem, but we think about them very differently. You know, I was talking to Stephen earlier, and we were talking about how in studio arts you have critiques, and in engineering school you have design reviews, and they're really very similar. They're trying to sort of accomplish the same thing, but also at some level they're very different. And so I think it would be interesting for HCI students to experience both the studio art critique mode and also the engineering design review mode, and think about how those things are both trying to help move towards a final completed work, but also sort of very different in spirit in terms of how people approach those things. This has not escaped other researchers and other writers. There were two reports that came out from the National Academy of Engineering, and one of these reports I think made a very interesting point that there is again, subtle difference between technological literacy and technological fluency. And so this Being Fluent report, which came out in the early 2000s, really tried to make this point that across all education levels in the United States, from K-12 up through undergrad, up through graduate school, that it might be interesting to think about how to educate students to be fluent in the technology rather than just literate with the technology, where in this sense, literate means I've seen it, I know it exists, but fluency implies that you can use it in a new situation that maybe you hadn't encountered before. And so one of the things that I've done at the University of Utah is to try and think about how I might use that idea of technological fluency in new courses that could be directed at all of campus, not just computer science or computer engineering majors. So I do have two courses that I could talk about if we don't have any questions that will take up the rest of the time. One that I teach with my collaborators in the sculpture area in the Department of Art and Art History at Utah, Kinetic Art and Embedded Systems. This is a course where we get students from both the computer science and computer engineering programs and also the sculpture program in the art department. We get them working together to build, design, and display kinetic, embedded, controlled sculptures. We very intentionally require them to work in groups that have both computer science, computer engineering, and artists, because even though the end result is a gallery show of the works that they've created, the educational result is that the students have learned a little bit about how to talk to the other students. And one of the things that C.P. Snow was talking about in The Two Cultures, and the National Academy of Engineering report was talking about with technological fluency, is if we can't even communicate, if we don't know the language of the other field that we're collaborating with, it's very hard to make progress. And it's not hard to learn to communicate with the two cultures. We just have to put ourselves in a situation where we learn and understand the two different cultures or the two different languages. So learning, having my engineering students learn to speak art and having my art students learn to speak tech is really the actual outcomes that I'm looking for, even though the gallery show is sort of the showy result at the end of the semester. And then I also have an interest in sound art, using sound as a medium instead of physical objects as a medium. And so I have a 2000 level course, which is freshman and sophomore level course for non-majors in using sound art to make noise. And the idea there is a very sneaky, I don't know if it's very sneaky, I intend it to be a little sneaky, intro to technology, but in the guise of making noise and making sound art. And so for that class, I'm sure you do the same at Iowa State, we have student evaluations at the end of the semester where they can make comments about what they've learned or what they didn't like. And my favorite comment from the Making Noise, Sound Art, and Digital Media class was a student who said, even though this wasn't the point of the class, I learned a lot about technology and programming, which is great. And I said to myself, but that was the point, and you didn't know it. It was great. It was perfect. So it was like if I had written the comment myself, it couldn't have been better than that one. So I do have some slides on those courses if you're curious, but come talk to me afterwards also if you want to hear about those. I don't want to take too much public time talking about these courses, but I'll just conclude and say that my thesis that I hope you also find interesting, at least at some level, is that artists benefit from knowing something about technology, technologists benefit from knowing something about art. There's this wonderful, if I use the Oreo technology terminology, we have a really nice arts chocolate cookie and we have a really nice technology chocolate cookie, but the magic is really in the filling in between that holds them together. So we all benefit from knowing a little about both. So with that, I'll be happy to take questions and talk at length about any of these topics that you found interesting. So thank you very much.
Questions?
What do you think are some of the biggest barriers at the moment to this happening? And is it changing?
There are so many sort of potential barriers, especially when you think about what you mean by this happening. If by this happening you mean having these cross-college courses that introduce students from different sides of campus and get them working together, one of the biggest obstacles is just administration who don't understand, and this is a crowd who can understand this, right? Who don't understand why you would want to teach a course with somebody in a different college, right? Why should part of my computer science teaching load be this course that I teach with the art department? Who gets the credit? I don't care, but some administrator somewhere cares who gets the student credit hour credit for that course. And I'm happy to give it to whoever's the loudest. So there is some sort of intellectual inertia on parts of at least some administrators. Some get it. There's also a little intellectual inertia in the two fields. I would say that I may be the only computer science faculty who would consider teaching this course. My collaborators in the sculpture area in the art department may be the only ones in the College of Fine Arts. I don't think they are, actually. I think College of Fine Arts is more open to this. But in the engineering school, I would say that it's not automatically something that the faculty would consider an interesting direction to go, unless perhaps they're in an HCI program.
How much cross-pollination do you see between the merging of art and technology and music and technology?
Great question. I focused really on visual arts because that's the courses that I've been teaching, but there's a very rich collaboration, at least possibly, between music and technology as well. I think we could probably talk about that as well. But in terms of, there are lots of ways to look at this. The easy way to look at this is sort of the technology of synthesizers and synthesized sound and music is clearly someplace where technologists were very important in the early days of sort of understanding how to do sound synthesis. Nowadays, how do you, suppose you have a video game that has, that will take the player 50 hours to complete. Do you compose 50 hours of music for that video game? Probably not. Do you figure out how to generate interesting, contextually appropriate music for what's going on in the game, but automatically generate it as the gameplay is happening because you don't know how they're going to react next? Yes. So now there's a really interesting question of how to do that so it sounds good and appropriate, but also gets generated algorithmically. If I delve into the sound art slides, I'll talk about people like Brian Eno, who's a pioneer in generative and ambient music, who has done music-based art installations with generative music techniques for many years.
Could you walk us through your thought process behind one of your artworks, one of your pieces?
One of my pieces?
Yes.
Sure. Oops, I'm going the wrong way. So this piece is a collaborative piece I did with sculptor Wendy Wisher. What had happened around Salt Lake City just before we decided to make this piece was that there was an oil spill in a stream that was coming down into the Salt Lake Valley. And this was a stream that was very pristine. It was actually in a protected part of a canyon, so it was very, very clean water. But it turns out, we didn't know this, but there was a Chevron oil pipeline that came through, and it polluted the stream, and it came down into the Salt Lake Valley, and it was really kind of a terrible mess. And so we thought, how can we address that issue and also address the idea of collaboration as a way of addressing environmental impact so that you could encourage people to think about how can I work with people to solve things, and it's not just me, it has to be a collaborative effort across different people. So we came up with this idea of filming the creek with recordings of the little babbling brook and then distorting it and using these physical mirrors to sort of distort that image and distort the sound, but then as people would collaborate and form a human chain between those hands, it would become more and more cohesive and resolve into a clean creek image and a clean babbling brook sound, whereas it was distorted and ugly before. That's a lot of conceptual baggage to put on a piece of sculpture. So we did have some little notes about, about what was going on, but that was the thought process behind this one. I won't go into quite as much detail, but the surveillance piece was really thinking about the surveillance state and how closed-circuit cameras are everywhere watching all of us all the time. And we don't know it, we don't pay attention to it, we don't see it, but these cameras are everywhere. And if somebody really did have access to all these cameras, they could track you wherever you were going within aims because all these cameras are here and you don't even know where they are. And so I frankly had discovered these kind of looming cameras in the university surplus with these little articulated arms, and I thought, oh boy, I got to use those. And so I bought all these little cameras, and then I built this city, and I put these little teeny people in it, and I had these cameras looming over them to imply that surveillance state. And then, just because I like retro CRTs, I made sort of a guard station that was watching over everything. And then I put other cameras in the gallery, so in addition to watching the static scene that's in the little city, there were also cameras watching the viewers in different places in the building. Yeah, my wife says I got to get rid of it because there are 20 different CRTs in our basement clogging up a lot of space, and she says, are you ever going to do anything with that? No, I don't know. It's great. I love black and white CRTs.
Excuse me. I had a question. How do you think your artistic endeavors have enhanced or furthered your research?
Haha. That's a great question. I have no idea. I think that, at some level, it is just a intellectual exercise in thinking differently about different things. And, one of the things that I especially say to undergraduates who, I don't know if it happens in HCI or in other departments that people are associated with, but in computer science and computer engineering, undergraduates hate general education requirements. Why do I have to take that humanities class? Why do I have to take that arts class? Why do I have to do this? I just want to take programming. And I tell them, well, I try not to sound lectury when I tell them, but I try and point out that as an undergraduate, this is your opportunity to study and learn about things that are not even in your area. You should embrace this opportunity, not dread it. You should look for a class in the fine arts, in humanities, in social science, in music, and embrace the opportunity to become a more well-rounded, intellectually interested person, which can inform anything you want to do later. You don't know how it's going to inform that later, but it will. And I don't know if anyone believes me, but I do try and preach that. So I think the answer is I don't see a direct connection between what I'm doing and my artistic side, but I'm sure it's there because it makes me more aware of connections between things that are not directly related to domain-specific computing. Now, the domain-specific computing that my students and I have been working on is involved in highly realistic computer graphics, ray-traced image generation, so maybe there's a connection there, but really, it's a little tenuous.
Just to build on that, since you've been a rotator at National Science Foundation for several years, how does your life of art and appreciation and thinking overlap with that?
Yeah, as Stephen implies, I'm professor at the University of Utah, but for the last 3 years I've been a program officer at the National Science Foundation, so I'm just coming back from that gig. One of the reasons, there are a number of reasons why one would do this silly thing, which is to give up your academic career for 3 years and go become a government bureaucrat at the National Science Foundation, reading proposals all day. One reason is to sort of give back to the community. I've been funded by NSF, and I really feel like I need to help out the younger researchers and give back by helping with the decisions that are made on research dollars. But when I went to the NSF, one of my interview slides was specifically about arts and technology and encouraging within the Computer and Information Science and Engineering, it's a mouthful, directorate at the National Science Foundation, which is where the computer science funding comes from, to encourage more opportunity for researchers who want to, not to force it on people who don't want to, but to encourage those, to have an avenue for those researchers who would like to involve artists in their research project to be able to get some funding to do that. And so one of the things, now I came at a very awkward time to do that because I got there in September 2019 and then in March 2020, everyone went home and we were virtual for 2 years, so I didn't really get to walk around the halls and talk to people as much as I wanted. But even though we're recording this, I think I can say that that is still something which we're working on. I can't promise any new program that's happening because we can't say anything about programs until they're released publicly, but I am still continuing to work at the NSF to help find a path for researchers who are already funded by the NSF in other ways to get supplemental funding to include artists and artists full stop, whether that's humanities, whether it's music, whether it's dance, whether it's visual arts, but to get artistic people involved in their research groups and to provide some supplemental funding to do that. So that's one of the reasons I went to NSF. I don't know how it will play out, but it's not dead yet.
Ben.
Hi. With the current trend of AI that everybody can pretty much press a button to create so-called artwork.
Yeah.
Do you think that this trend will be the threat to the art industry, or you think that the art industry will embrace this AI technology?
That is, we need to go out and have a drink and talk about that for hours because that's a long conversation. I think the short answer is that history has shown that every time there have been dire predictions about the death of art because some new technology that artists have adapted and found new ways to either incorporate that or to find other modes. So, this very same question was asked earlier in the 20th century about photography. Now that we have photography, is painting dead? Because at the time, at least some people were thinking painting is about making realistic images of life, and now we have this new technology that's better at doing that. So, oh, painting's done. Well, it turns out painting wasn't done. And you can look at other inflection points in the art world where people have had the same conversation. Will this be the death of fine art? This one admittedly seems like a pretty interesting inflection point, but I think that in my optimistic moments, I'm convinced that artists will adapt and that art will move in new directions to find new ways of expressing itself. It certainly will democratize basic artworks. I think the fact that pretty much anyone can make kind of a weird, interesting image using an image generator now is kind of interesting, but I think the same way that desktop publishing didn't make everybody a Pulitzer Prize-winning author, AI-generated artworks won't make everybody a well-respected artist. So I hope it doesn't cause too much trouble.
Yeah, we'll do one more after Kimberly.
Hi. So I have lots that I want to chat with you about, but in this kind of public forum, I guess I'm curious if you could think about an asymmetry here between the art and the technology, where in this mode you are an artist, your medium are objects and instruments and visions that are created technologically, but in fact it's an art production.
Okay.
So, and it's also social commentary.
Yes.
Right?
Yep.
And at the beginning of the talk when you were showing us the avant-garde artists, a piece that's often lost is that that's all social commentary as well, right? I
Yep.
mean, there's so much to say about those artists
Yep.
and where they were and why.
Yep.
So I wonder if on the technology side, if you could say a little bit about how the same thing could happen where it's not an engineer making art, but it's actually a technologist who's using technology the way that art has functioned, which is as social commentary, as a way to have experiences and thoughts that are outside of functionality, that are beyond the things that we absolutely need to do. Art is a kind of, gives us a consciousness beyond the absolute need. So can you think about the mirrored situation where technology doesn't just become art, but it actually tries to do something that's more functions the way that art operates in our society? I don't know if that question is too much to ask.
Wow. Are you sure we can't go get a drink and talk about this?
Bring the architectural historians.
Wow, so many different directions I could go with that. I think, in some sense, what differentiates somebody who uses Stable Diffusion to make a picture of a cat and an artist who's making a social comment that involves an image that looks like a cat? And fundamentally, what is different about those two things is the content, is the intellectual content, it's the message, it's the underlying intent of making some sort of comment on the world through that image. And perhaps maybe that's as good a definition of art as any, that, Marcel Duchamp said, I can't unfortunately say it in French, but he said, what can I make that is not art? And so for him, everything that he did, his life, his games of chess, everything that he does, how can you say that what I'm doing is not art? How can I do something that is not? And of course, we could take that to extremes, but I think perhaps one of the things you're getting at is that this social commentary, this idea of having a conceptual basis for why you are doing this, is in some ways what makes it art as opposed to a pretty image. And so the person who engages in that contextualizing, in that conceptual basis for what you are doing, is an artist regardless of what direction they've come from. And so, I don't want to sound too grandiose, but, this is me as an artist because I do have a conceptual basis. You can agree with my conceptual basis. We can argue over whether it's relevant and whether I've done a good job of sort of expressing that conceptual basis. But I did have a conceptual basis for this piece. And so in that context, I'm not a computer scientist, I'm an artist. On the other hand, if I made a pretty image of my dog, which I have also done, that might have just been a technological trick to make an image that I found enjoyable. So, but yeah, wow, what a thesis statement for improved, for expanded discussion.
All right, well, let's